So today we will be exploring the transverse wave. So what is transverse wave? So transverse wave is generated through a vibration. Particles are vibrating perpendicular 90 degree to the direction of the wave. So when the vibration produced is vertically, the waves moves horizontally. So this means that the particles are moving up and down, going to the direction of the wave's motion. So take a look in the attached GIF on the slide. So one hand is actually holding the spring, and it continuously moves it from to an up and down motion that creates a vibration. So the waves here oscillates in an up and down, going to a horizontal direction. So another example for us to visualize this type of wave, which is the transverse wave, is this line of people, line of military men actually holding their firearms. So the from the very first person which actually move up and down and in domino effect until the very last person demonstrated the transverse wave. So the people here are actually the particles in the medium. So they move up and down, that creates a wave from left to right. So this wave actually gets its name, which is transverse wave, because the particles motion is transverse to the direction of the wave. Okay, transverse wave can be mechanical or electromagnetic in nature. First is the transverse mechanical wave. So it is a type of wave which requires a medium in order to propagate or transmit energy from one place to another. So this medium can be solid, liquid, or gas. So this means that this type of wave requires matter in order to propagate. So for example is the vibrating string and sound waves. On the other hand, the transverse electromagnetic wave is a type of wave which can not only travel through air in solid materials, but also through the vacuum of space. So this means that this type of transverse wave doesn't require or need matter in order to propagate. So for example is the light and radio waves. All electromagnetic waves are considered transverse, but not all mechanical waves are considered transverse, because we have also other category for mechanical waves, which is the longitudinal wave. The different parts of the wave. So first, we have the crest. So crest is the highest point of the wave, or it is the top part of the wave. Next is the trough. So the trough is the lowest point of the wave, or it is the long narrow depression in between waves or ridges. The pulse is a segment from a crest to a nearby trough. So amplitude is the measure of the distance from the equilibrium to the crest, or the distance from the equilibrium to the trough. So wavelength is the distance of a complete wave. So this is actually the illustration of the transverse wave. So it illustrates here the crest, the trough, the amplitude, the wavelength, the direction of the travel, which is horizontally, and the direction of the disturbance, which is vertically along the equilibrium position, which is it just like the straight line dividing the wave. Next is the measures of the wave. So first is the frequency. Frequency is the number of cycles of a wave passing a point per unit time. So the formula for frequency is equal to 1 over t. So the t here is the period per second. Next is the period. So the period is the time required to complete one cycle wave. So formula is period is equal to 1 over the f, which is the cycle per second. Next is the wave speed. So wave speed is the rate of movement of the disturbance. The formula here is wave speed is equal to the square root of the frequency over the density, or wave speed is equal to the square root of the frequency divided by the mass over the length. Okay, we go now to the relationship between wave speed, wavelength, and frequency. So first, as the wave speed increases, the wavelength decreases and vice versa. So, in the illustration, as the wave speed increases, so we can see that the wavelength or the measure of every peak of the wave is decreases. So, that's it. Next, as the wave speed increases, the frequency also increases. So, as the wave speed increases, so its frequency also increases. So, the frequency is the measure of how many cycles of a wave per unit time. So, it also increases as the wave speed increases. Next is, as the wavelength increases, the frequency decreases and vice versa. So, when the wave speed decreases, or if the speed of the wave decrease, so it creates a wide wavelength. So, its wavelength increases. And the cycle, which is passed per unit time, is of course decreases, or its frequency of course decreases. So, thank you very much. So that's all about the transverse wave.